All right, so this is our video on solving exponential equations. It starts with a warm-up of 3 problems, so go ahead and try those on your own. Don't forget about population growth, bacterial growth, radioactive decay is all using PERT. All right, here are your answers. Okay. All right, let's go ahead and see what we're talking about today. So first off, I don't know what font this is, but I'm not in love with it, but no, seriously. First off, you have to remember your exponential properties. We have to use these when solving the following problems. So what we have to remember is a to the first power, the rule with exponents. So the properties a to the first power is the same thing as a. Rule with words stays the same. Okay. All right. A to the negative m power. You cannot leave negative exponents in your answers. So if the exponent's negative, drop it like it's hot, meaning put it on the bottom or make it into a fraction that becomes 1 over a to the positive m. So drop it to the denominator. Drop it like it's hot. If you have 1 over a to the negative w, bring it to the top. You can't have negative exponents, so that becomes a to the w. Anything that is 0 power is 1. If you have a to the m times a to the n, you keep your base and add your exponents, so that becomes a to the m plus n. If you have the a to the m raised to the nth, so a power to a power, you keep your base and multiply your exponents. And then if you have a to the m divided by a to the m, you keep your base and subtract your exponents. Or you can say, where's there more, keep them there, and take away that from the opposite side of the fraction bar. Okay, so what we're going to do is we're going to use some of these properties to solve equations. These are on the simpler side. In the next lesson, they get a bit more complicated. Okay, so here it says solve each equation using properties of exponents. So I want to solve this equation using my properties of exponents. So it says 3 to the 5x is equal to 27 to the 2x minus 5. So first off, I want to look at my bases of 3 and 27 and see if I can rewrite them as the same base. Ooh, which I can. 3 is 3 to the first power, so leave it alone, but 27 is 3 to the third power, so let's rewrite it like that. So leave 3, I don't have to write 3 to the first power, but leave this as 3 to the 5x is equal to, rewrite 27 as 3 to the third power, and then we have 2x minus 4. All right, so now we can solve this because 3 to what power gives you 3 to what power? So these two things have to be equal in order for it to be true. So we have 5x is equal to, distribute that 3 there, that becomes 6x minus 12. Subtract 6x from both sides, you have negative x is equal to negative 12, so x is equal to positive 12. You should not have to check your answers due to the fact that exponential functions, if you look at a sketch of here's growth, here's decay, right? Their domain is all real numbers. Therefore, every x value that you get should work as long as you solve correctly. Okay, here's the next one. 1/2 to the x power is equal to 2 to the x plus 2. So if you look at the bases, we want to rewrite them as the same base. They both can be rewritten as a base of 2. The right-hand side already has a base of 2, 2 to the x plus 3. The left-hand side, 1/2 could be rewritten as 2 to the negative first power. And then we have that to the x power. Power to power, multiply your exponents. So we have 2 to the negative x, or negative 1x, is equal to 2 to the x plus 3. And now, in order for this to be true, these have to be equal to each other. So we have negative x is equal to x plus 3. Subtract x from both sides. We have negative 2x is equal to 3, divide by negative 2. And we have x is equal to negative 3/2. Glorious. Okay. See? Wonderful, right? As long as you know your properties. All right, if you look at your bases on the next two, 2 and 16, 3 and 27. These might even be easier than the last two, right? So we can rewrite both 2 and 16 as a base of 2. 2 is 2 to the first power, so I'm just going to leave it. 16 is 2 to the fourth power, and then we have x minus 5 still. Power to a power. not power to a power, but we just have to multiply that out. So we have, this must be equal to this. So we have x plus 1 must be equal to 4x minus 20 in order for this to be true. Subtract x from both sides. Add 20 to both sides. We have 21 is equal to 3x. Divide by 3. X is equal to 7. Voila. Here's the next one. Both can be rewritten as a base of 3. 3 to the first power is already there. 27 is 3 cubed. X minus 2 must be equal to 3, so x is 5. Good, right? So easy. Like I said, we're doing easy ones here. All right, looking at the next one. Our bases are 3 and 7. You can't rewrite 3 and 7 to have the same base. So notice this lovely calculator right here. So we are going to use our calculator to find the solution, okay? So in order to do that, what we're gonna do in our calculator is we are going to go into y equals, and we are going to put two equations into y equals, and we're gonna find out where they intersect. The x value at which they intersect is the solution, okay? So we're going to do y1 is equal to 3 to the x, and y2 is equal to 7. Where they intersect, that will show us a solution. Of course, we could do any of our equations this way, but all the other ones are no calculator. All right, let's see if my calculator's ready to go. Fingers crossed. Come on, yes. All right. I don't know what that means, so I'm gonna ignore it. Okay, so we have y equals, so click your y equals. In y1, I'm gonna do 3 to the x, 3 to the x power. In y2, I'm gonna do 7. What happened to my x power? And I keep tapping it like it's a touch screen, which it is not. Okay. All right, so now I'm going to hit graph. My calculator reset to factory standard settings. So it's gonna go to that -10 to 10, -10 to 10 graph paper. So in case yours isn't, you could always hit zoom 6, which is zoom standard, and it'll show that regular graph paper. And then we might have to fix it so we can see it, but nope, here it is. All right, that intersection, the x value of that intersection is our solution. So we are going to hit second trace, which is calculate. Option number 5 is intersection. If you see the intersection on your screen, you basically have to hit enter 3 times. It says, are you on the first curve? Yes, enter. Are you on the second curve, which is our line y2 equals 7? Yes. Should we guess what the intersection is? Yes, please. So our solution to this is x equals 1.771. Remember, we round to 3 decimal places unless otherwise stated. So if you look at that decimal, I rounded it, but if I put 3 to that, 12437, 12437, 12437, 12437, 12437. Man, 12437. I have short-term memory loss. Oh no. 12437, I think. You should get around 7. See? Okay. It cut it off, just like how we rounded, but it is the solution. All right, let's go ahead and do the next one. Okay. The base here is 2. The base here right now is 18, but there's this 3 hanging out. So let's get rid of that 3 by dividing both sides by 3 so we can actually judge this. 2 to the 4x plus 3 is equal to 18 divided by 3 is 6. So then I look at my bases. Can I rewrite 2 and 6 is the same base? No. Some people will say, yeah, you can write it as 2 times 3. That's not rewriting a function with the same base raised to a power. It's like 2 to what power would give you 6? Nah, I don't know that. So we're gonna use the same method that we used on the last one, okay? We're gonna do in y1, we're gonna put the left-hand side of the equation, or the right, it doesn't matter. And in y2, we're gonna put the right-hand side. So y equals 2, oops, I should probably clear this out, 2 to the 4x, finance, no thank you. Y equals 2 to the 4x plus 3. And then here's 6. Hit graph. Once again, if it's not on your screen, you could always adjust it so it is, but this is going to be on my screen. Boom. I see the intersection. It's right there. I do second, trace. Option number 5 is intersection. Enter, enter, enter. It'll say intersection is at the x value, which is negative 0.104. Right? Okay, great. All right, let's get away from calculator problems and let's start doing more by hand. Notice no calculator here, so bye-bye, calculator. Bye-bye. Get out of here. Close. There you go. Okay. All right, let's go ahead and do these. So let's pretend like we don't know if we can use our calculator. Look at the bases, right? I can rewrite 8 as 2 cubed, and then that's x minus 1. 2 is 2 to the first, leave it alone, x plus 2. Set these equal to each other. 3x minus 3 is equal to x plus 2. Solve for x, subtract x from both sides, add 3 to both sides. 2x is equal to 5, divide by 2, x equals 5 halves. Wonderful, right? Here's the next one. All right, looking at your bases, you can rewrite 144 is 12 squared. And really what you're doing, like, I should, instead of just like writing the 12 squared and then we're going like this, 2x plus 1, I should be saying, I'm gonna back it up, Terry. There we go. I should be saying this is 12 squared to the 2x plus 1, and then you can see it's a power to a power. Keep your base multiplier exponents. But I go straight to, all right, that's what I'm here with, right? Equals 12 to the 5x minus 1. 4x plus 2 is equal to 5x minus 1. Subtract 4x from both sides. Add 1 to both sides. We have x is 3. Okay, let's move on to the next two. 4. Okay, 4 left. We can do this. Look at your bases. Why don't you try the next two? Pause the video, try them on your own. Try the next 4. Okay, and then if you need to fast forward through me to see if you got the answers right, do it. Or just go straight to the answer key and see if you got them right. 2 is 2 to the first, so we're going to leave it as 2 to the n plus 1. 16 is 2 to the fourth, and then I'll end up with a power to a power, so I'm going to multiply my exponents, n plus 7. So set those two equal to each other. M plus 1 is equal to 4m plus 28. Subtract m from both sides, you have 3m. Subtract 28 from both sides, you have negative 27. Divide by 3, you have m equals negative 9. Okay. Looking at the next one, I can rewrite 1/3 as 3 to the negative first, and then that's to the x plus 2, power to a power. Multiply your exponents. 3 to the x minus 1. Set your exponents equal to each other. Negative x minus 2 is equal to x minus 1. Add x to both sides. Add 1 to both sides. You have x equals negative 1. Okay, did I make a mistake there? Negative 2, subtract x from both sides. Or add x to both sides. It's 2x. I lost my x, that's why. It didn't look, it felt too wonderful. Add x to both sides, that's 2x. Add 1 to both sides, that's negative 1. Divide by 2, x equals negative 1/2. I got very lucky there to catch my mistake. Okay. Next one. 16 and 8 can both be rewritten as a base of 2. So this is 2 cubed to the 5x power, which means multiply your exponents. 2 to the 4th, 2 to the 3x plus 4. Multiply your exponents. Same base, so now you can set your exponents equal to each other. 15x is equal to 12x plus 16. Subtract 12x from both sides. 3x is equal to 16. Divide by 3, x equals 16/3. Okay. Last one, 2/3 and 8/27. So we can rewrite them both to the the numerators as 2s, the denominators as 3s. So we'll leave this as 2/3 to the 5x plus 1. This is 2/3. 2 cubed is 8, 3 cubed is 27, and then we have to the 4 minus x. So once again, I'm just going to go like that. And now you have a power to a power, set your exponents equal to each other. 5x plus 1 is equal to 12 minus 3x. Add 3x to both sides, that's 8x. Subtract 1, that's 11. Divide by 8. X equals 11/8. Ooh, I do not like writing fractions like that. Don't start now. Okay. All right, that's it, right? Totally. All right, so that's it for today. Well, that's it for this lesson. You can go ahead and start working on some homework, or notice that today we also have some review after this with more difficult problems than this. So I'm going to make a screencast on those problems that are slightly more difficult, maybe 1 or 2, fingers crossed. And then the rest of the review will be for you to work on along with your MML.